Have you ever tried to rub the balloon with your hair and took it close to the cold drink can? If you try this, you will see magic. All of us have the experience of seeing a spark or hearing a crackle when we take off our synthetic clothes or sweater, mostly in dry weather. Have you ever tried to find any explanation for this phenomena? We will answer all of these questions in this lesson on electric charge and force. So let's get started this video. You probably know what happens if you rub the balloon with your hair and take it closer to the cold drink can. You may even know that it is caused by something called static electricity. But do you know what static electricity is and why it makes cold drink can become attractive to the balloon? To answer these questions, we have to start with the atom. Everything in the universe made up of atoms, and every atom contains three types of particles called protons, neutrons, and electrons. The protons and the neutrons are packed together in the nucleus at the center of the atom, while the electrons zip around the outside in constant motion. For our discussion on electricity, we only need to concern ourselves with protons and electrons because they have property called electric charge. It is a scalar quantity. The electric charge that electrons and proton possesses is responsible for the form of energy that we commonly call electricity. Protons have a positive charge, which is easy to remember because the word proton and the positive both starts with the letter P. Electrons, on the other hand, have a negative charge, which is equal but opposite to the charge on a proton. If you bring one electron and one proton together, their charges cancel each other out, and we say that together they have no net charge. But in most atoms, there are equal number of protons and electrons, so the atom itself has no net charge. However, there are many atoms that either give away electrons or accept more electrons with relative case. When this happens, we call the atom an ion. If an electron goes away, then the atom is left with more protons than electrons, and the atom becomes a positive ion. Likewise, if an electron comes along and joins the atom, then there will be more electrons than there are protons, and the atom will become a negative ion. The transfer of electrons from one atom to another happen all the time. Remember, rubbing a balloon on your hair, this is a great example of transferring electrons. But why does it happen? The answer is your hair contains atoms that are happy to give away some of their electrons. On the other hand, the balloon contains atoms that want to accept those electrons and hold on to them. Therefore, when you rub the two together, a bunch of electrons transferred from your hair into the balloon. As a result of this transfer, your hair becomes positively charged because its atoms were left with more protons than electrons, and the balloon becomes negatively charged because its atoms had more electrons than protons. So the balloon has ability to attract the uncharged object like a can. Now you understand what electric charge is and how it transfers. A very important observation from the above example that we didn't destroy any electrons to build up a positive charge on your hair, and we didn't make more electrons to build up a negative charge on the balloon. All we did was transfer the electrons from one place to another. This concept is known as conservation of charge. It doesn't mean that charge is neither created or nor destroyed. In a beta decay process, a neutron converts itself into a proton and a fresh electron is created. We will discuss this in the nuclear chapter. Well, the charge of an isolated system is conserved. It is not possible to create or destroy the net charge. The above discussion suggests that charge is a basic property associated with the elementary particle, and its definition is as difficult as the definition of mass or time or length. We can measure the charge on a standard body, but we do not know what exactly it is that we intend to measure. The SI unit of charge is coulomb and abbreviated as capital C. 1 coulomb is the charge flowing through a wire in 1 second if the electric current in it is 1 ampere. The charge on a proton is 1.602 multiplied 10 to the power minus 19 coulomb. The charge on an electron is the negative of this value. I hope you understand the concept of electric charge and how it works and its basic property, that is the first property, that is law of conservation of charge. Now there is a one question for you guys that you can assess yourself that you understood the concept or not. The question is, the object may acquire an excess or deficiency of charge by, options are electric force, heating, shaking, and the last one by rubbing. Answer this question in the comment box. At the end, I will see you in the next video. Bye guys.